All right, so let's talk about some more selective breeding stuff. You can see in this picture, we've got some corn, we've got cows. Let's look at the slide. It says some benefits of selective breeding include drought-resistant plants and animals that grow larger and faster, food animals that gain weight faster, cows that produce more milk. So all of these things, if you think through what selective breeding is, let's go back to that first slide. Selective breeding is the process of choosing organisms with specific desired traits to be parents. And the goal of that is to have offspring that have certain characteristics. So we can take plants, two plants that whatever the specific trait is. Let's say we planted some plants and it was a really, let's say corn or okra. Let's say okra. We planted some okra and the majority of the okra did not do well. Maybe 10% of what we thought was going to grow grew. Those ones that died because of not having enough water. They did not have enough water to sustain them. And so those plants, we could consider the plants that grew to be more drought resistant than the ones that died. And so the ones that grew that year, we could take those seeds, plant them again the next year, or maybe if it's a really fast growing crop, do it again this year. But we plant them again and we continue that process over and over, not watering them too much, just enough to get started and let them go. And every time we do that, those genetics get stronger and stronger and stronger towards the trait that we want. And it is somewhat of a gamble, but the more you do it, kind of like with Mark Shepard, the more you do that, the more you roll the dice, the more the dice give you what you want. So let's talk about some examples of selective breeding. So we've got inbreeding. So inbreeding is the crossing of two individuals that are genetically similar. The crossing of individuals that are genetically similar. So this could be, you can see down here at the bottom, it says, for example, a turkey farmer may choose a male and female turkey that are both really plump and are fast growers. Now, if you're eating turkey, you want a turkey that's going to give you a lot of meat if you're raising them for meat. And so having a really nice plump mom and a really nice plump dad having a baby, you get a higher chance of that offspring having the traits that you want, which are nice and plump. And then once you get the genetics going for and being nice and plump, then you start having the ability to start moving towards another trait. So it's not super easy to, kind of like with Mark Shepard, where he let the cold kill off a lot of the trees first. And then he started selecting for early pollination, early fruiting, early blooming plants. He didn't do both at the same time. He did one, and then when he was done with that, he did the next one. And sometimes there needs to be a lot more time that's in between things. So you see in this turkey, it says when they pass on those traits to their offspring. But when you're doing that, remember, it's a gamble. So if I bred these two turkeys together, they may both have recessive genes, kind of like Greg Mendel's pea plants. They may have genes that are recessive, but in the offspring, they show up. And so it still is a gamble. But it's you can look at the probability and see if the probability is high or low. Inbreeding is a word you may have heard before. Inbreeding with royalty, a lot of times throughout history, royalty saw fit to inbreed. So it says, in the past, royal families in many countries practiced inbreeding in the belief that their royal bloodline should be kept pure by marrying into the family. And this means that cousins married each other, that in some situations, like in, I believe it's Aztec and Egyptian histories, that the brothers and sisters will actually do that as well. And so there's a bunch of odd practices that we would consider odd, but the concept is the same, that those genetics, they would want those genetics of whatever royal blood looks like. They want that royal blood to continue on for the next generation. You wouldn't have a king marry a peasant or a king marry a non-royal person because you want that bloodline to be pure. So I think a lot of times we see this as odd, but back in several hundred years ago, or especially thousands of years ago, they would see this as more that this makes sense. You can kind of see this in this picture at the bottom left, but in some species, inbred individuals, the more you inbreed something, the more you mate individuals with their with relatives, especially with the same genes, then things can start popping up that are not beneficial. So you see this pug that its eyes are not okay, the pig that has multiple, it's got like, a head and a half, it's not exactly right, and the lizard or the salamander has more legs than it should. These recessive genes that would normally if you're breeding with an offspring or breeding with another organism that is not in the same gene pool, so it's not in the same family, then these recessive traits tend to stay recessive. But the more you start breeding within the same family, within the same very small gene pool, you start having these problems that pop up. And you can see that in them. You can see, I don't remember what this is. I want to say this is France. It may be England, but I'm not sure. So what happened with the royalty, they started, because they were so inbred for generation after generation after generation, there were some deformities that started popping up. So those deformities would normally be a recessive trait that doesn't pop up. But because organisms in the same gene pool keep breeding, then if you think about that Punnett square with heterozygous and heterozygous, then eventually the chances of a homozygous recessive popping up is going to be pretty high, or it's going to get higher and higher as you breed. So if you didn't understand that, go back, pause the video, and do a Punnett square with heterozygous and heterozygous, and look how many homozygous recessive you get. All right, selective breeding to the extreme. You can click on this if you want to. This is kind of a cheesy, creepy video, a creepy, cheesy video, stuff they don't want you to know. It talks about eugenics, but eugenics is the idea of being in control of the genes that you pass on. And we see this as okay with plants and animals most of the time. We don't see this okay with humans. So the United States dabbled with this. If let's say somebody was a serial killer and they were convicted, and it was, sure enough, the people were sure enough that this person did those bad things, the government would step in and actually make it to where they cannot have babies. They would do surgery to where they could not have any children. And so some people, you might say, well, that's okay because those people are bad. Well, when you give the government right to do that to some people, there's very little stopping the government from doing that to larger groups of people. And so you can look at that and see how what America did, Germany kind of picked up on, the Nazis picked up on, and then you have things like the Holocaust that happened. But you can click on that video and look at it. Hybridization. Hybrid, remember that hybrid meaning that there's two things that are different, a difference. Hybridization is when breeders cross two organisms that are genetically different. So when you do this, you're hoping that the best of both parents comes in. So I remember there's an old joke that said that Albert Einstein and Marilyn Monroe, Einstein being known for his intelligence and Marilyn Monroe being physically attractive. They were at a party one day, and somebody walked up to Einstein and said, "Hey, you should have a baby with Marilyn Monroe because then your children would be beautiful and super intelligent." And to which Einstein, which I'm sure did not actually happen, but the concept is what I'm trying to explain to you. Einstein said they could be really smart and really beautiful, or they could be really dumb and really not beautiful, which was assuming that, Albert Einstein was not attractive and that Marilyn Monroe was not very intelligent. Both of which I think you can easily argue against, but that's the idea, that if you put two things together, you're hoping that you get the best of both worlds, but you might get the worst of both worlds. So that's hybridization, when you put two, inbreeding is when you put two things that are genetically similar. Hybridization is when you put genetically different and you're hoping the best things show up. You can see hybridization happens with a donkey and a horse making a mule, two different qualities of each. You can see it with a tiger and a lion. But what happens with hybridization oftentimes is things are not able to reproduce. The hybrid that comes, like the liger, is not actually able to reproduce because it's not an actual species. It's a mixture of species. And then cloning. Cloning is a way of asexual reproduction. You can kind of read through this, but a lot of things can reproduce asexually. We talked about it already, but cloning is an example of that. It can happen naturally, and we can actually kind of hijack this and make things. We can clone things on our own as well. So there's other things that we've done: sheep, animals, stuff like that. And then genetic engineering. You can read this. Talk about this later.